My name's Ian Paterson. I'm the Market Development Engineer at Vinidex. And today's webinar will be looking at what defines best environmental practice PVC. Now, if you've got any questions during the course of the webinar, just use that raise your hand function or put them in the Q&A area and I'll try and answer them as we go. I don't think we'll need the full hour by any stretch. So if anything doesn't make sense along the way, I'm more than happy to go back over it. So the term best environmental practice or BEP PVC has been around for over 15 years. You'll see it marked on conforming PVC pipe and fittings, but what's actually required to achieve that conformance? So we'll start the webinar today with a short history of PVC pipes in Australia, followed by details of the PVC pipe and fittings life cycle from resin production through to PVC pipe manufacture and finally to end of life. We'll then have a look at what led to the development of best environmental practice PVC, discuss the BEP requirements in detail, and then finally how this all relates to the Green Building Council of Australia's Green Star credits. So the PVC life cycle starts with chlorine production, then it's followed by the production of ethylene dichloride or EDC and vinyl chloride monomer VCM production. VCM is then used to produce PVC resin, which in turn is used to manufacture PVC pipe and fittings. The final stage of the life cycle is when the pipe reaches the end of its useful life, some 100 years later, at which point it can just be recycled into brand new pipe. The PVC production process is the world's largest single use of chlorine. It consumes about 35% of the chlorine produced worldwide. PVC is made up of 57% chlorine by mass, which is sourced from readily available common garden variety salt. And the chlorine is extracted from the salt by the electrolysis of a brine solution. Now, there's three main industrial methods for the extraction of chlorine by electrolysis. The first is the mercury cell electrolysis, which was first introduced around the late 1800s, but it's the least energy efficient of all the three methods. There's also concerns around mercury emissions associated with this process. The second method is diaphragm cell electrolysis. It also dates back to the late 1800s, but it's more energy efficient than the mercury cell. Its main disadvantage is that large amounts of steam is required during the process, and it may use an asbestos diaphragm. The third method is the membrane cell electrolysis, and it was only developed in the 1970s, and it's the most efficient by far of the three methods of chlorine production, and it doesn't use mercury, and there's no asbestos involved in the process either. And the process is actually, it's got many similarities to your typical saltwater pool chlorination system, and it results in some byproducts of hydrogen and caustic soda or sodium hydroxide. The first stage in converting that chlorine to PVC is to make ethylene dichloride, or as I said before, EDC. So ethylene is derived from hydrocarbon raw materials, and chlorine together are reacted in a chlorination process to form EDC. The EDC is then decomposed through a thermal cracking process, resulting in the vinyl chloride monomer, VCM we talked about, as well as hydrogen chloride. That hydrogen chloride is then further reacted with ethylene and oxygen to produce more EDC and water, and so the process goes on. And then the final step in the production of PVC involves a batch reactor process where VCM is polymerized with itself or co-polymerized with other compounds. This polymerization process can be undertaken in several ways. say suspension, emulsion, bulk or solution, but they all result in the production of PVC resin, the main ingredient, obviously, in PVC pipe manufacture. So in manufacturing PVC pipe, that PVC resin, along with additives that include pigments and stabilizers, are weighed and processed through high-speed mixing to blend the raw materials into a uniformly distributed dry blend mixture. Now, those stabilizers are necessary to aid in the processing of the PVC and to prolong the life of PVC products, while pigments are used for color, that's for identification purposes, and for UV protection. But the heart of the process, the extruder, has a temperature-controlled zone barrel in which rotate precision screws. Now, modern extruder screws are pretty complex devices. They're carefully designed with varying flights to control the compression and shear developed in the material during all stages of the process. The twin counter-rotating screw configuration used by all manufacturers these days offers improved processing over the older systems. The PVC dry blend is metered into the barrel and the screws, which then convert the dry blend into the required melt state by heat and pressure and shear. And during that passage along the screws, the PVC passes through a number of zones until the melt is actually extruded through the head and die set. And once the pipe leaves that extrusion die, it's sized by passing it through a precision sizing sleeve with external vacuum. And at that point, it's sufficient to harden the exterior layer of PVC, and we've actually got a pipe which can hold its shape and diameter during final cooling in a controlled water cooling chamber. The pipe's pulled through the sizing and cooling operations by a haul-off at a constant speed. And that speed's really important when this equipment is used, because the speed at which the pipe is pulled will affect the wall thickness. If it's pulled too hard, you'll get a reduction in wall thickness. If it's too slow, it'll increase the wall thickness. So that's critical to maintaining that accurate wall thickness. An inline printer then marks the pipe at regular intervals, and an automatic cut-off saw cuts the pipe to the required length. And then finally, a belling machine forms a socket on the end of each length of pipe, and that's your PVC pipe production process in a nutshell. And then finally, we come to the end of life that we talked about. But PVC's pipe's durability and robustness give it a life expectancy in excess of 100 years. So we're talking a long time after the pipe production and installation to it finally reaches the end of its useful life. And when they do reach that point, they're actually 100% recyclable. So old pipe and fittings and other PVC waste can be recycled straight back into new pipes. And studies have shown that PVC pipes can be mechanically recycled up to 10 times without losing their technical properties. And because PVC pipes are manufactured from a single type of highly stable material, recycling is relatively simple. PVC can easily be reprocessed into new pipes with exactly the same life expectancy as those original pipes. So it's important to understand that the plastics used in PVC pipe and fittings are vastly different to the single-use plastics that you see in flexible packaging, for example. So, some plastic packaging might be made up of multiple polymers. It might incorporate other different materials like aluminium foil. And this can make plastic packaging of that nature quite difficult to separate and recycle. And when we talk about recycling plastic pipes and fittings, there's three basic types of recyclate. The first is post-consumer recyclate, and that's plastic material that's generated by households or by commercial, industrial, institutional facilities, and they've basically fulfilled their intended purpose and they can no longer be used. The second type of recycled plastic is pre-consumer recycler. And this is plastic material that's diverted from the waste stream during a manufacturing process or from unused products, but it doesn't include a manufacturer's own rework or regrind or scrap. That's a separate category. That is the third type of recycled material. The rework material is plastic scrap generated from a manufacturer's own production. So for a pipe manufacturer, that might be scrap material generated during the manufacturing process. For whatever reason, that product may not be acceptable. So it's reprocessed and reused as rework material. Now, the Australian product standards allow the use of post-consumer, pre-consumer and manufacturer's own rework material in non-pressure pipe and fittings. Their use in pressure pipe and fittings is very limited, but for non-pressure pipe and fittings, we have a lot more opportunities to use that recycled material. As well as that, smart multi-layer extrusion technology allows this recycled material to be sandwiched between layers of virgin PVC material. Just like you can see in that image on the right of the slide there, that's actually some heavy-duty electrical conduit with a layer of recycled material sandwiched between an inner and an outer layer of virgin orange PVC material. So we'll move on now to the development of best environmental practice, pardon me, in Australia. And there's a little bit of background history involved in this. In the lead up to the 2000 Olympic Games in Sydney, which were billed as the Green Games, Greenpeace got involved and issued PVC minimisation guidelines for the Games. And as a direct result of this Greenpeace action, eliminating and finding PVC alternatives wherever possible was written into various Olympic tenders and contracts. And it resulted in a pretty long running agenda to clean up or totally eliminate PVC products. And this agenda was picked up by the US Green Building Council and ultimately by the newly formed Green Building Council of Australia. And it resulted in their own Green Star PVC minimisation credit. So where you would actually get credits for minimising the amount of PVC in your project. Now, ironically, at that time, Australian PVC pipe manufacturers had already eliminated many of the nasty additives that the US Green Building Council and Greenpeace, they were promoting it as universal, and that included the use of heavy metal stabilizers, chlorine containing mercury, that sort of thing. So it took some pretty detailed and extensive collaboration between the PVC pipe industry, including the Vinyl Council of Australia and the Plastic Industry Pipe Association, or PIPA. And together with the Green Building Council of Australia, it prompted the establishment of a comprehensive review into what actually defined best environmental practice PVC. And so in April 2010, 10 years after the Sydney Games, following a review by an expert reference panel, the Green Building Council of Australia published the Green Star PVC materials credits in the Green Star rating tool. And this established the criteria for best environmental practice PVC. And that covered its manufacture right across its life cycle. And then finally in 2013, those BEP PVC requirements were written into every Australian and New Zealand PVC pipe and fitting standard. So enshrined into those Australian and New Zealand standards. So best environmental practice PVC provides a framework for a reliable, safer, and a lot more environmentally friendly way to produce PVC products. It takes into account PVC's whole supply chain, from the production of PVC resin, the use of additives, the manufacture of finished goods, through to considerations around end of life. And as I mentioned previously, the health and environmental concerns that are sometimes associated with PVC are simply not applicable to Australian PVC pipe products, with specifications covering additives that are some of the tightest in the world. Australian PVC pipes contain no plasticizers, which contain phthalates, which are known to have negative effects on the endocrine and reproductive systems. There's no dioxins in Australian PVC pipe that can cause reproductive and developmental problems. Australian PVC pipe also contains no heavy metal additives or stabilizers, which means no lead, mercury, or cadmium. So safe drinking water is one of the most important requirements for health in society, and PVC pipe and fittings are designed to provide the highest level of safety for carrying drinking water. They don't corrode, and they have superior chemical resistance, protecting drinking water from contaminants. Now, all these BEP PVC requirements across the entire supply chain have now been incorporated into a brand new Australian standard. So a standalone standard, if you like, AS/NZS 5395, best environmental practice, PVC pipes and fittings. This standard is recognised by the Green Building Council of Australia, and it's a pretty significant milestone in the PVC industry, as it's the only standard of its kind in the world developed specifically for PVC pipe and fittings. So all PVC pipe and fittings must be independently assessed and certified as part of a rigorous regulatory environment that provides confidence that these products meet all the requirements of the standard. The standard provides consumers with peace of mind, knowing that they're choosing safe, environmentally friendly and high quality PVC products that align with the vision for a healthier, resilient and a circular built environment. How we go? Have we got any questions so far, Internet?
Yes, Ian, we've got one from Kasab. It's design life of 100+ years if installed below ground. How about above ground outdoor environmental installation?
Well, no, that's a good question. Obviously, when a pipe is installed above ground, there's a lot more environmental considerations to look at. So, you know, we're talking about UV exposure, temperature, wind may even have some sort of effect. So, look, still in the right conditions, if the pipe is formulated correctly and installed and designed correctly, a 100-year service life is still achievable for above ground installations. Just as with any installation, we just have to make sure that, as I said, that it's designed correctly to suit that particular purpose.
That's all the questions for now.
All right, we'll move on for now then. So just looking at some of the specific criteria for best environmental practice, starting with chlorine production. So chlorine must be produced from either a membrane cell or a modified diaphragm cell, which doesn't include asbestos. That mercury cell electrolysis we spoke about earlier is simply not acceptable. The chlorine mustn't be produced from plants using graphite anodes either, as they produce high levels of carbon dioxide, which consume the anode. Vinyl chloride monomer, or VCM, must be sourced from non-mercury production processes. And, pardon me, EDC and VCM must be sourced from closed-lid production plants that implement emissions controls for water, air and waste emissions. Further, VCM emissions from raw PVC resin mustn't exceed prohibited limits when it's delivered to the end processor of that resin. And that resin must be sourced from plants with strict emissions targets, with an environmental management system in place. So a lot of criteria to meet just in the PVC resin production alone. Then looking at PVC pipe production and the criteria there, cadmium, lead and hexavalent chromium stabilisers and pigments aren't acceptable as per all Australian PVC pipe and fittings product standards. There is one exception to this, and this is simply where legacy post-consumer recycled PV material that might contain some of these elements, it can actually be used in the core of sandwich construction or multi-layer products. So similar to that, that sandwich construction conduit I showed you a few slides ago, that legacy post-consumer recycled material can be enveloped within those layers of virgin PVC material quite acceptably. Other requirements include no phthalate plasticizers that I spoke about before, and any claims of recycled content used in the manufacturing pipe and fittings need to be properly verified. And then finally onto the end of life management criteria. So any arrangements for end of life management must be in place through one or more of take back programs, waste programs, or any other initiative that diverts waste from landfill. And these are typically agreements with customers for extended supplier responsibility or product stewardship. These extended supplier responsibility agreements include arrangements to take products back at the end of the product's in use phase for some form of recycling or reuse. They can also include arrangements with recycling and waste transport service providers for the collection of end-of-life product and delivery of that product to a recycling service provider or the manufacturer, who can then reuse and or recycle that material. Now, I spoke earlier about the Plastics Industry Pipe Association, or PIPA, and they have very recently published an updated version of their industry guideline, POP 106. And this is a companion document to the Australian standard, Australian New Zealand standard, AS/NZS 5395, pardon me. And it's to be read in conjunction with the standard. Now, this guideline is separated into two sections. The first section provides an overview of BEP pipe and fittings, and it includes background information about the development of BEP criteria, essentially what I've covered today. Section 2 provides verification guidance for PVC pipe and fittings to be BEP conformant. This section is particularly useful for manufacturers and conformity assessment bodies, or CABs. This document is available for download directly from the PIPA website at absolutely no charge. So let's look at some of those means for demonstrating conformance. So to conform with AS/NZS 5395, it must be confirmed by one of the conformity assessment bodies, or CABs, that I spoke about, who must be registered with and accredited by JASANS at intervals not exceeding 5 years. Conformance covers the manufacture of PVC resin and PVC products, as well as recycled material end-of-life considerations we've already spoken about. And the standard requires PVC pipe and fittings manufacturer to provide and maintain a declaration of conformity as a means of demonstrating ongoing compliance with many of these BEP requirements. So they're quite detailed requirements, and responsibilities are put on manufacturers. So starting with how do we demonstrate PVC resin conformance? So this can be achieved in one of two ways. Firstly, the PVC resin manufacturer can provide their own BEP PVC certification, or product manufacturers can collate the declarations from all the stages of the supply chain into one document. Now, collating the declarations for each stage of the supply chain involves mapping all those stages of manufacturing PVC resin. And that each of those processes that might take place in one integrated location, or it could be in one or more separate locations. As PVC product manufacturers may source from multiple resin suppliers, it's important to ensure that each of the stages of manufacture are captured and documented. So this is usually provided in the form of a flow chart, which provides full transparency of the source of PVC resin or any precursors that are used in the manufacture of PVC pipe and fittings. So in addition to these PVC resin requirements, controls on additives represent best practice in the manufacture of PVC pipe and fittings. So to demonstrate that cadmium, lead and chromium stabilizers and pigments are not used and PVC pipe and fittings don't contain stabilizers, manufacturers have to include suitable process control like purchase documentation, technical specifications or safety data sheets in their documentation. So looking at that supply chain mapping I spoke about, so it involves product manufacturers producing a flowchart like the one you see here, which shows the complete supply chain for their products. And that has to include the name and the location of each of the supplier plants. So this allows an auditor, it allows the CAB to clearly see where each component of the PVC resin and its constituent products are sourced. So as you can see in this example, there's numerous pathways that can be taken in a supply chain. For example, producer A in this case, it's an example of a fully integrated plant that produces all the components in the supply chain, right through from chlorine production to the PVC resin production. Producer B, on the other hand, is a partially integrated plant that produces the EDC and VCM and the PVC resin, but it sources the chlorine from another producer. And then we've got producer C, which only produces PVC resin, and it might source their EDC or VCM from either producer A or producer B. So whatever the pathway, PVC pipe and fittings manufacturers have to document the source of every component in the supply chain, allowing full process transparency. Recycled material can be used in non-pressure pipe and fittings, as we've mentioned, and it can be incorporated in the core of sandwich construction, multi-layer pipe that we've seen also. But any claims of recycled content, be that post-consumer or pre-consumer recyclate, must be verified. And evidence of conformity might include process control documentation, product specifications, or even signed contracts. Moving along to end of life and aligning with the key principles of a circular economy, being 100% recyclable at the end of PVC's useful life, it can be remanufactured into new products. So this can be achieved through a combination of the take-back programs and waste programs that we spoke about, or the implementation of other innovative end-of-life initiatives, such as the one you see here. Although the volume of waste PVC might be low due to the long life of PVC products, end-of-life management provides an avenue to capture that PVC material and diverting this valuable resource from landfill. So evidence of conformity in this case may include documentation again, website information, or contracts and waste programs or take-back programs, all that sort of things, as long as there's some sort of documentation of any of those programs. So how does this BEP PVC relate to the Green Building Council's Green Star credits? So the Green Building Council has what it calls a responsible products framework, and this sets out the criteria for all product certification schemes or similar initiatives that are can be assessed against if they wish to be recognised by the Green Star program. So a responsible product is defined as a product or a material that has a responsible product value, or RPV, and that's issued by an initiative that's recognised by the Green Building Council of Australia. That RPV, it's a score given to an initiative after assessment against the responsible product guidelines. And then applying the Green Star Buildings tool, the RPV can then be used to achieve Green Star credits. Now, some of the initiatives recognised by Green Star that apply to PVC pipe and fittings include BEP PVC that we spoke about, and also product-specific environmental product declarations. So these environmental product declarations, they're a standardised and verified way of quantifying the environmental impacts of a product based on a consistent set of rules known as product category rules. An environmental product declaration, or EPD, includes transparent and comparable data, as well as other relevant environmental information about the life cycle environmental impact of a product. So multiple data sets are included in an EPD, such as resource consumption of energy, water, and renewable resources, as well as emissions to air, water, and soil. And this data is aggregated using multiple environmental impacts, including contributions to climate change, or otherwise carbon footprint, air, water, and soil pollution, as well as resource depletion. Other relevant impacts and environmental information may also be included, which might include data on product performance, the company's environmental management system, or other environmental certification. So Vinidex has EPDs for all its manufactured product groups. So looking at these responsible product value scores, so as part of these, the Green Building Council's recognition of the ASNZS 5395, it's been assessed against the responsible products guidelines for initiatives. And this assessment was over several categories, including environmental management, chain of custody, OH&S, chemicals of concern, and waste generation. And the end result was a total responsible product value, or an RPV, assigned to best environmental practice PVC of 7. So then, in addition to that RPV score of 7 for the BEP certification, a product-specific environmental product declaration gives you an additional RPV of 5. So with a combined RPV of 12 for responsible systems and Green Star projects, these products are then considered good practice products in the responsible systems and finishes product credits of the Green Star project. And then on top of that, that RPV for responsible systems in Green Star projects, material efficient PVC pipe and fittings allow us to reduce our carbon footprint even further. So products such as PVCO and PVCM pressure pipe use advanced manufacturing technology to reduce the amount of material required. PVC stormwater and sandwich construction PVC use manufacturers' own rework, post-consumer and pre-consumer PVC waste in the sandwich core layer, which is directly responsible for the successful diversion of a useful PVC from landfill in Australia. XGuard, a newly released twin-wall corrugated PVC conduit, provides a strong material efficient product using an innovation formulation. So there's all sorts of options available in that material efficient PVC pipe and fitting space to reduce your carbon footprint even further. So just wrapping it all up, so despite some negative perceptions around PVC, there's actually significant environmental benefits. As I've said, PVC is 100% recyclable. It has a life expectancy of 100 years, and it can be mechanically recycled up to 10 times without losing its technical properties. By applying the Green Building Council's Green Star Buildings tool, PVC pipe and fittings can actually achieve Green Star credits. And by publishing this Australian New Zealand standard 5395 as a standalone standard, the first of its kind worldwide, it signifies Australia's leadership in the field of best environmental practice PVC. This new standard shows the plastic pipe industry's commitment to ensuring the highest level of safety and environmental considerations. Best practice accounts for the entire supply chain from raw material production, pipe manufacture, through to end-of-life considerations. And we believe that this is a really significant milestone in the PVC pipe and fittings industry, contributing to a healthier, resilient, and circular built environment. So, do we have any questions? What have we got?
No questions in the Q&A.
Nothing in the Q&A. What about from the floor? Anyone with any questions? I'll take that stunned silence as a no. And with that, then we might wrap this up then. Look, I hope you were able to get something out of this webinar, and it does give you a better understanding of why best environmental practice PVC is so important to our industry, and that you've been able to at least getting a basic understanding of what the requirements of us as an industry is involved. So with that, I'll close up and yep, sorry.
Sorry, Ian, we just got one come through.
Yep.
It's just from Stephen Law. Is there a risk imported finished PVC pipe systems could contain harmful materials and heavy metals with imported product?
Oh, look, it is certainly a risk, but as long as they undertake the best environmental practice process and they're able to provide full supply chain mapping as part of that process, that certainly mitigates the risk. But if they're not interested in conforming with the BEP requirements, definitely there's certainly a risk that those imported products might contain some of those additives that we're definitely trying to avoid as an industry.
And then just one more from Casey Cox. What will happen with existing BEP certificates?
Well, those certificates are still current. The ones based on the original standard. So when each individual product standard had its own BEP requirement, certification based on those standards is still current. There is a transition period between those standards and the standalone BEP standards. So yes, still current during this transition period.
And I just wanted to check with Stephen Law, did you have another question, or was that the one that was in the Q&A? You can unmute yourself if you'd like to ask.
Thank you. Yeah, I've just actually fired through another question, just following on from my original question. Is AS NZS 5395 mandatory per se with sensitive products, i.e. electrical conduit and cable duct, so forth, you know, water pressure pipes, etc.? Is it a mandatory standard, 5395, I guess is the question?
Well, it's mandatory in the sense, you know, if you want to be a responsible manufacturer, that yes, you need to meet these requirements, but there will always be instances where the AS NZS 5395 isn't referenced, say in a specification. So the onus is essentially on responsible manufacturers and responsible suppliers to implement the standard. So I wouldn't say it's mandatory in that sense. It's more just certainly responsible manufacturers will take this up in any case.
Yeah, so I guess the opportunity for us as an organisation would be to maybe talk to asset owners and get them to reference this particular standard in their specifications, so it eliminates all the risk, right?
Exactly. Yep. No, you're spot on, Stephen. Yeah.
It would be good to maybe spend some time on this, particularly here in New Zealand, maybe putting something together so we can educate the industry on this, because I think the challenge for us here is there's all these standards, manufacturing standards in particular, that sit behind the scenes, let alone installation standards, and the industry is struggling to keep up to speed. So I think we've got an obligation to also share this with external stakeholders as well. So yeah, I'd really appreciate maybe some, slides, maybe 3 or 4 slides that can help us influence some of those decisions with key asset owners here in New Zealand. That would be really helpful, because that's key. I think it's like you said, it's getting something in the specification that references the asset owner requirements.
Yeah, absolutely, and I'm more than happy to assist you there, Stephen. And really, that's one of the main reasons why we're doing what we're doing today is to spread the message and to get those asset owners on board with the requirements of this standard.
I think that's it, Ian.
That's it.
There's
okay,
no more.
we will wrap it up there, and thank you everyone for your attendance, and enjoy the rest of your day.
Thanks, Pato.
Thank you. I think we might get started. If there's any late arrivals, we'll just let them in as